Salam uşaqlar, axşamınız xeyir. Necəsiz? Bugün deməli 45-ci gündür. 45-ci gündən davam edirik. Öncə səsi falan bir dənə yoxlayım. Əla. Hər şey qaydasındadır. Səs də normal işləyir. Gəlin davam edək. Deməli bundan əvvəlki günlərdə də elə threads mövzusuna baxmışdıq. İndi də oradan davam edəcəyik. Belə. Ups. Ay, sorry, səs əgər biraz pis gəlsə. Hə. Yep. Notlardan davam edəcəyik. Bir dənə ekran görün qaydasındadır. Məsələn, indi sizdə deyəsən yenə ekran o deyil. Okey, hər dəfə olur zaten bu. Görə mən ekranı bir dəfə yenidən dəyişim. Niyə belə olur, mən anlamıram. Olsun. Okey. İndi görək qaydasındadır, qaydasındadır. Axırıncı dəfə qaldığımız mövzu nə idi? Yəni buralardaydı. Buradan memory model oxumuşduq və memory modeldən sonra nə edirdik? Volatile keyword zad. Bunu oxuduq, yox, volatile keyword bu bir, ikinci. Bu nə edir? Bunu oxuduq. Nədir? This method allows, yenə yadımdan çıxdı məsələn bu hissə. Method 1 and method 2 to be executed concurrently but guarantees that access shared variables for E and J occur exactly as many times and in exactly the same order as they appear to occur during execution of the program text by each thread. Therefore, the shared value for J is never greater than the value for E, because each update E must be reflected the shared value of E before update to J occurs. It's possible, however, that any given invocation of method 2 might observe a value for J that is much greater than the value observed for E, because method 1 might be executed many times between yəni normalda bu sonra memory yazılır, shared memoryaya, sonra bu yazılır. Yəni heç vaxt C i-dən böyük olmayacaq. Amma thread istifadə edəndə ola bilər ki, bu oxunarkən i-nin köhnə dəyərini oxusun, C-in amma təzə dəyərini oxusun. Ya da i-ni oxusun, bunu oxuduğu müddətdə C çoxlu update geçsin digər thread tərəfindən və s. Bu getdi. Burada memory modeli oxumuşduq, ardından shared variable baxdıq. Burada actionlar var. Actionlardan əvvəl amma bizə lazımdır bu final field-ə baxacaqdıq. Amma gəlin öncə 17, 5, 14, 2 gəlin actionlara falan baxaq, ardından bir gedək bura kimi. Okey. Deməli açaq. Burada harada qalmışdı? Burada qalmış deadlock. Ardından burada deadlock falan baxacaq. Deməli actionsda nədir? Okay. An interthread action is an action performed by one thread that can be detected or directly influenced by another thread. There are several kinds of interthread actions that a program may perform. Read, normal or non-volatile. Reading a variable. Write, normal or non-volatile. Writing a variable. Synchronized actions, which are volatile read, a volatile read of variable, volatile write, a volatile write of variable, lock, locking a monitor, unlock, unlocking a monitor, the synthetic first and last action of a thread. Actions that start thread or detect that thread has terminated. Bu yəqin ki interrupt'u nəzərdə tutur, or notify o falan onu. Synchronization order. 14.4. Okay, buralara gələcəyik. Deməli, external actions hansı ki bunlar deməli several kind of interthread actions that program may perform. External actions. An external action is an action that may be observable outside of execution that has a result based on environmental external to the execution. Thread divergent actions. A thread divergent actions is only performed by a thread that is in infinite loop, in which no memory, synchronization, or external actions are performed. If thread performs a thread divergence actions, it will be followed by infinite number of thread divergent actions. Görə bu nədir? Non-terminating execution. Nəysə, buralara gələcəyik. The thread divergent actions are introduced to model how thread may cause all other threads to stall and fail to make process. This specification is only concerned with interthread actions. We do not need to concern ourselves with intra-thread actions, adding two local variables and storing the result in third local variable. As previously mentioned, all threads need to obey the correct intra-thread semantic for Java programs. We will usually refer to interthread actions more
succinctly.
Oops. Eşitmirəm.
Succinctly.
Succinctly.
Succinctly.
Okay. As simple actions. Mənası nə deməkdir? Let's see. Yığcam şəkildə. When I refer to interthread actions more succinctly as simple actions. Deməli, an action is described by tuple comprising thread performing the action, the kind of action, the variable or monitor involved in the action. For lock actions, where is the monitor being locked? For unlock actions, where is the monitor being unlocked? If the action is a volatile or non-volatile read, where is the variable being read? If the action is a volatile or non-volatile write, where is the variable being written? U is an arbitrary unique identifier of the action. An external action tuple contains an additional component which contains the result of external action as perceived by thread performing the action. This may be information as success or failure of the action and any value read by action. Parameters to the external action, which bytes are written to which socket, are not part of external action tuple. These parameters are set up by other actions within the thread and can be determined by examining the intra-thread semantics. They are not explicitly discussed in the memory model. In non-terminating execution, not all external actions are observable. Non-terminating executions and observable actions are discussed here. Bu heç nə başa düşmədim mən bu hissədən. actions, photo, look, ne bileyim falan, bunlar okey de bunlar nədir? Programs and program order. Among all intra-thread actions performed by each thread T, the program order of T is total order that reflects the order in which these actions would be performed according to intra-thread semantic of T. A set of actions is sequentially consistent if all actions occur in total order, the execution order, that's consistent with program order. And furthermore, each thread, each read error of variable v sees the value written by the variable w to v such that w comes before r in the execution order, and there is no other w such that w comes before w. Oi. What is that? Demen nə deyir? Each read R of variable v sees value written by w to the r. Write comes before read in execution order. There is no other write such that write 0 comes before write 1 and write 1 comes before r in execution order. Yəni demək istəyir ki, write readdən əvvəl gəlir və bu writedan başqa bir write yoxdur və başqa bir write yoxdur ki, bu r-dan readdən əvvəl gəlsin. Sequential consistency is a very strong guarantee that made about visibility and ordering in execution of a program. Within a sequentially consistent execution, there is a total order over all individual actions, such as reads and writes, which is consistent with the order of program. And each individual action is atomic and is immediately visible to every thread. If a program has no data arrays, then all execution of program will appear to be sequentially consistent. Yəni heç bir data arrays yoxdursa, həmişə consistent olacaq. Sequentially consistent and or freedom from data arrays still allows errors arising from groups of operation that need to be perceived atomically and are not. If we were to use sequentially consistent as our memory model, many of compiler and processor optimizations that we have discussed would be illegal. For example, in trace, as soon as the write of 3 to px occurs, subsequent read of that location would be required to see that value. Deməli, sequentially consistent əgər memory model istifadə edəsək, bu halda write of 3 to px occurred, subsequent reads that location would be required to see that value. Px üçün yazılması. Px üçün yazılması. Would be required to see that value. R6'nın ardıcıl oxunması bu write'ın tələb edirdi. Let's ask GPT. Explain this. Each thread has its own program order. The order instruction appear in your code. Program order A equal 1 happens before B equal 2 in this thread. Sequential consistency means all actions, read and writes from all threads can be arranged into one single timeline. Timelines respects each thread's program order. Each read sees the value of latest write in that timeline. In other words, it's as if all thread takes turn one at a time and everyone sees updates instantly. And thread 1 x equal 1, thread 2 int r equal x. In sequential consistent world, if 1 happens before 2 in the global order, then r must see 1. If 2 happens before 1, then r must see 0. No other weird outcomes are allowed. Why Java doesn't enforce sequential consistency always? Is too strict. It would forbid many compiler CPU optimization like reordering, caching, register reuse. Example from the documentation: if thread 2 writes px3, then in sequential consistency, all later reads to px must immediately see 3. That would make optimization like reusing old read illegal. R5 equal R2. Data race consistency sequential. JVM compromise: if your program has no data race, all shared variables are properly synchronized, then program behaves as if sequentially consistent. Yani hiçbir data race yoksa sequentially consistent olacak. That means safe multi-threaded code feels like sequentially consistent. If there is a data race, then all bets are off. JVM CPU may reorder, cache, and produce paradoxical results. Group of operation: even under sequential consistency, you can still get logical errors. Non-atomic check then act may interleave incorrectly with other threads. Each individual read-write is atomic and ordered, but the group of them is not. Multiple threads could run this at the same time and break logic. Simple takeaway: program order, the order of actions in single thread. Sequential consistency: all threads' actions interleaved into one global timeline, preserving each thread's order and instant visibility. Java only guarantees sequential consistency if your program has no data race. You use synchronized, volatile, or atomics. Without synchronization, a JVM or CPU can reorder and you lose sequential consistency. Let's see. Sequential consistency versus reordering, not sequential consistency. The menu: thread 1 x equal 1, r1 equal y, thread 2 y equal 1, r2 equal x. Each thread writes one variable, then reads other. Sequential consistency: bu da 1'di, bu da 1'di. Global order. Timeline B. Okay, bu nedir? Sequential consistency varsa necə bu sıfır olur? Bunu 1'ə bərabər elədi. Gəldi bunu run elədi. Sonra bunu run elədi. Sonra da bunu. Burada sequential consistency olmadı aha. Y equal 1. R1 equal Y. X equal 1. R2 equal X. Yəni demək istəyir ki, əgər birinci bu thread run olsa, bu 1 olacaq, bu 0 olacaq, bu 1 olacaq, bu da 0, 1 mi? Ya da birinci bu thread run olsa 1 olacaq, 0 olacaq, 1 olacaq, 0 olacaq, 1 olacaq, bu da 2, 1 mi olacaq? Without synchronization, JVM allows reordering. R1 equal Y. R2 equal X. Okay, global order. Bu necə sequential consistent olur? Mən bu timeline B və timeline C'ni anlamadım. Okay. Possible. Impossible. This outcome looks impossible under sequential consistency, but it's legal under Java relaxed model when there is data race. All actions interpolate into one global timeline, preserving program order. Impossible. Java without synchronization. Can reorder becomes possible. You need volatile, synchronized, or atomics. Mən deməli sequential consistent'də I don't understand timeline B and C in how does those happen? Sequential concept, which means all actions from all threads can be placed into one single global order. Yəni buradakilərin hamısı bir dənə ordera gedə bilər. Yəni birinci ola bilər thread 1'in X-i gəlsin, sonra thread 2'nin bu, sonra başa düşdük. Deməli sequential consistency nədir? Hər iki threaddə olan datanın bir dənə single threaded application'a order olmasıdır. Deməli, burada da nə baş verir? Birinci bu run olur, sonra bu okay. Burada thread 1 x equal 1 before r1 equal y preserved. Thread 2 y equal 1 before r2 equal x violated. Burada yeri dəyişir məsələn. Must come after program order. So that's why mistake. That was my mistake earlier. Deməli timeline Tez ses normaldırmı? Aha. 1. Ups. Niye böyle oldu? Şimdi bu. Ha, okey, ses qaydasındadır. Səsdə problem olsa deyin də inşallah zəhmət olmaz. Heç bir problem yoxdur məncə. Hə. GPT-nin yazdığı hissədə qalmışdıq. Deməli, bu deyir ki, bayaq yazdığım timeline B düzgün deyil. 1-1 olur. Another possible is interleaving y equal sees 1. İkisi de 1'i görür. R1. Okay. Ben bunu düzeltti öyle ki bu geldi. Sonra bu biri geldi, ardından da diğerler ardıcıl olarak. Burada necə oldu? Y is 1. Belə bir şey. Necə olur? Bəs burada thread 1'in ikinci line'ı gəlin run olaraq birinci. How is this possible? Thread 1's first line is executed before thread 1's second line. Reads before thread 1 writes it. 1 reads by before thread 2 writes it. Ay, bu GPT nəsə boş danışır, səhv izah edir, böyük ehtimal. Neyse. Biz nəyə baxaq? Yazaq. Sequential consistency in Java. Threads. Bir nəfər da bizim kimi boşa düşmüş. Operation on shared queue. The lines of code for each thread are numbered and initially the queue is empty. Thread A, A1, NQ, DQ, thread B, NQ. Assume that order of execution as follow NQ, NQ, and DQ. And as a result, we get Y. The queue returns Y. This execution is based on well-known book and it's said to be sequentially consistent. Notice that method call don't overlap. How that even possible? I believe that thread A executed A1 without actually updating the queue. Thread A executed without updating the queue until I proceed to the line A2, but that's just my guess. I'm even more confused if I look at this explanation from the Java language. Sequential consistency is a very strong guarantee that is made about visibility and ordering of execution of program. Within a sequential consistent execution, there is a total order over all individual actions such as read and writes, which is consistent with the order of program. Each individual action atomic and immediately visible to every thread. If that was case, I would have the QX. Görək nə deyir? Consistent with program order, not consistent with the order in which program happens to be executed. not consistent with the order in which the program happens to be executed. It goes on say, if program has no data race, then all execution of program will appear to be sequentially consistent. My emphasis of appear, Java memory model does not enforce sequential consistency. As the GLS says, if we were to use sequential consistency, our memory model, many of compiler and processor optimizations that we have discussed would be illegal. For example, in the trace in table, as soon as write to px occurs, subsequent read of that location would be required to see that value. So Java memory model doesn't actually support sequential consistency, just the appearance of sequential consistency. And that only requires that there is some sequentially consistent order of actions that's consistent with program order. Clearly, there is some execution of threads A and B that could result in A2 returning Y, especially B and Q, then Q. Y, Q, and Q. So even if the program happens to be executed in the order you specified, there is an order. Okay, bu ne deyir? Bu da deyir ki there is an order in which it could have been executed that's consistent with program order, for which A2 returns Y. Therefore, a program that returns Y in that situation still gives appearance of being sequentially consistent. Note that this shouldn't be interpreted as saying that it would be illegal for A2 to return X because there is a sequential consistent sequence of operation that's consistent with program order. Ayda. This shouldn't be interpreted as saying that would be illegal for A2 to return X because there is a sequentially consistent sequence of operations that is consistent with program order that could give that result. Note also that this appearance of sequential consistency only applies to correctly synchronized program. If your program is not correctly synchronized, has data race, then all bets are off. Okay, yani dedik ki eğer program synchronizedsa, hiçbir data race yoxdursa, sequentially consistentdir. Sequentially consistent de o deməkdir ki, consistent with the order in which program happens to be executed. Proqramın execution order'ı olduğu kimi qalır. Yəni məsələn thread A-da belə bir ardıcıllıq var, thread B-də də belə. Bu deyir ki, ola bilər birinci thread B execute olunsun, sonra thread A hansı ki DQ-da Y qaytaracaq. Sonra nə deyir? Bu cümləni başa düşmürəm. So even if program happens to be executed in order you specified, there is an order which it could have been executed. Sən deyir ki, sənin verdiyin orderda da, bu specify elədiyin orderda da execute olsa, there is an order in which it could have been executed. Burada deyir, hər hansı bir order var ki, o execute oluna bilər. Hansı ki, proqramın orderına consistentdir. Hansı ki, A2 Y return edir. Program that returns Y in that situation still gives appearance of being consistently sequentially consistent. Because there is a sequential sequence of program that is consistent with program order. Yəni deyir ki, bu proqram elə bir orderda execute oluna bilər ki, hansı ki proqram orderla consistent olsun və A2 y return etsin. Amma deyir, biz bunu elə başa düşməməliyik ki, A2 x return edə bilməz. Çünki there is a sequentially consistent sequence of operations that is consistent with program order that could give that result. There sequentially consistent olduğu üçün hər hansı bir orderda y return edə bilər, amma bu demək deyil ki, x return edə bilməz. Amma bu data race olmadığı halda olur. Yəni data race olmadığı halda olur. Data race olmadığı halda okey. Data race olmadığı halda necə olacaq? NQ, DQ qaytardı x'i, sonra bu NQ oldu. Sonra NQ, NQ, DQ qaytardı y, hansı ki sequentially, nə bilim, synchronized. Okey. İndi mən necə başa düşməliyəm? Başa düşməliyəm ki, sequentially consistent o deməkdir ki, əvvəlcə hər hansı bir threaddəki bütün ardıcıllıq execute olunacaq, sonra digər threaddəki ardıcıllıq execute olunacaq. Beləmi? Çünki nəticədə synchronize. Synchronize nə deməkdir? Bir deməli shared variable hər ikisi eyni anda dəyişiklik edə bilməz də, düzdür? Məncə düz başa düşmüşəm. Gəl bunu bir dənə 11 il əvvəl yazılıb. Yeni söhbət bu işə köhnəldi. Should I understand sequential consistency as a way that each thread can each thread can access none of those threads can access shared variables at the same time because of and it could return x if executed like this. And y if executed like this. And never can be executed like this because of sequential consistency. Görə düzmü başa düşmüşəm? Nəsə artıq GPT-yə heç güvənmirəm. What sequential consistency actually means does not mean that thread can't access shared variable at the same time. It also does not mean that real execution order is preserved exactly. It means all operations from all threads can be arranged into single total order, like timeline. This total order respects each thread's program order. Each thread sees the value written by most recent in that thread total order. So sequential consistency about existence of some timeline that makes execution look consistent, not about forbidding reordering at the hardware compiler level. Okay, reordering mümkündür. Sadece o iki thread'in de execution'ı bir dənə single thread kimi olur. Why you can see why even though you listed A1, B1, A2, your listed execution order looks like it must decue X, since X is FIFO, but sequential consistency, the important thing is, can we find some equivalent interleaving that is consistent with program order and explains why Y is returned? Yes, if we instead view the interleaving as that's perfectly legal sequential consistency scheduling, A still respects its order. Okay. Still respects its order, only B1. The total order is consistent with both threads program order. Yəni hər birində A1, A2-dan əvvəl gəlir, B1-daki özü üçün bir dənə sətirdə gəlir. The FIFO queue naturally returns Y because Y was enqueued before X. So even if real low-level execution happened, sequential consistency only requires that there is existing some global order consistent with thread program order when the observed result makes sense. That's why returning Y is sequentially consistent. So, okay, mən başa düşdüm ki, A1, A2-dan əvvəl gəldiyi üçün, B1 da özü üçün hər hansı bir yerdə əvvəl gəldiyi üçün bu sequentially consistentdir. But why returning Y is sequentially consistent? Burada nə oldu? Burada nə oldu? X oldu, Y oldu. Bu return eləməlidir. Important thing is, can we find some equivalent interleaving that is consistent with program order since Y was returned? This is valid sequential consistency could return X. This is valid sequential consistency could return Y. This looks like breaks FIFO, but it's still sequentially consistent because we can reinterpret it as if the logical timeline was yani deyir bu da sequentially consistent'tir. Y return eləyir. Çünki biz bunu reinterpret edə bilərik as B comes before. Sequential consistency doesn't say this is exactly how it happened. Whatever happened, we can pretend there was a single timeline of atomic operations consistent with each thread's order that explains the result. So, both X and Y are possible results. Sequential consistency does not forbid returns Y case because there exists a sequentially consistent timeline that explains it. Bu state diagramını göstərsin, görək necə göstərir. Okay, burada GPT düzgün izah elədi. GPT-ni korrekt eləməyə çalışanda artıq elə bilir ki, sən düz deyirsən və səhv cavablar verir. Ona görə sual verəndə korrekt etmədən niyə belədir deyə sual vermək lazımdır. Bu niyə belə işləyir, mən başa düşmürəm. Deməli, initial queue, enqueue, dequeue, enq elədi, x var. Deq elədi, return x. B1 enq y. Result is x. Sonra y. Bunu da enq elədi. Deq eləyəndə y return elədi. Textbook confusing order still returns y. A, B1, A2, initial Q, X, B1 and Q, X, Y. But wait, that looks like it returned X. Sequential consistency let us re-explain this execution as if logical order was A2 legitimately returns Y. That's why both results are consistent with sequential consistency. Physically, the runtime might schedule A1, B1, A2. Logically, under sequential consistency, system is free to pretend it was B1, A1, A2, as long as thread local order is preserved. That's why sequential consistency is about the appearance of single timeline, not literal CPU order. Okay, deməli sequential consistency single timeline'da hər iki threadin actionlarının yerinə yetirilməsidir. CPU order barədə deyil. Təzən onu orderunu dəyişə bilər. Sequentially consistent execution zamanı. Okay. Don't synchronize has data race. Only applies to the if the queue itself correctly synchronized. Yani sequential consistency'nin özü də ancaq synchronized olanda keçərlidir. Okay, bu volatile necə işlədiyi maraqlı. Buna baxaq. Okay, buna baxaq. Bu nədir? Oy, bu nədir? Well, onun keçəyi buna baxaq, o çox çətin görünür. Deməli, how volatile in Java works, example of volatile keyword in Java. Deməli, what is volatile variable in Java and when to use volatile variable in Java is a famous multi-threading interview question in Java interviews. 2023'də yayınlanıb. Though many programmers know what is volatile variable, they fail on second part. Where to use volatile variable in Java, as it's not common to have clear understanding and hands-on on volatile variable in Java. In this tutorial, we will address this gap, provide a simple example of volatile variable in Java discussion, when to use volatile. In a way, volatile keyword in Java used as indicator to Java compiler and thread that do not cache the value of this variable and always read it from the main memory. Okay. Okay, burada gələrik. Heap main memory. Hotspot hotspot heap structure. Young generation bu şey barədəydi. Permanent generation neydi adı? Unuttum. Garbage collection. Okay, buna da gələk, buna da oxuyaq. Öncə bunu oxuyaq ama. Ama öncə zaretka. Şarjımız azalır. Well. Okay. So if you want to share any variable in which read and write operations is atomic by implementation, like reading and writing in an integer or an Boolean variable, then you can declare them as volatile variable. From Java 5, along with major changes like auto-boxing, enum, generics and variable arguments, Java introduced some changes in Java memory model, which guarantees visibility of changes made from one thread to another. Also, as happens before, which solves the problem of memory writes that happens in one thread can leak through and be seen by another thread. Okay. In Java, volatile keyword cannot be used with method or class, and it can only be used with variable. Java volatile keyword also guarantees visibility and ordering after Java 5 writes to any volatile variable happens before any read into volatile variable. Okay, writes to any volatile variable happens before any reads into volatile variable. By the way, use of volatile keyword also prevents the compiler or JVM from the reordering of code or moving away from them from the synchronization barrier. Deməli, use of volatile keywords also prevent compiler or JVM from the reordering of code or moving away from them from the synchronization barrier. What is volatile variable in Java? An example. Understand example of volatile keyword in Java. Let's go back to singleton pattern in Java and see double-checked locking in singleton. With volatile and without volatile keyword in Java, with volatile or without volatile keyword in Java. Okay, singleton pattern. Double-check locking on singleton pattern. Java program to demonstrate where to use volatile keyword in Java. In this example, singleton instance is declared as volatile variable. Every thread sees updated value for instance. Deməli, private static volatile singleton instance, volatile variable, instance null'dan fərqlidirsə, synchronized singleton class. If instance null'a bərabərdirsə, instance equal singleton. İki dəfə belə check yazdığına bunu silib bunu bir dənə synchronize'ın içərisinə yazsan niyə? If you look at the code carefully, you will be able to figure out we are only creating instance one time. We are creating instance lazily at the time the first request comes. If we do not make the instance variable volatile, then thread which is creating an instance of singleton is not able to communicate other thread, and that instance has been created until it comes out of singleton block. So if thread A is creating singleton instance and just after creating lost the CPU, all other thread will not be able to see the value of instance as not null, and they will believe it's still null. Okay. Thread engine, thread variable, main memory. Let's save. Because reader threads are not doing any locking, and until the writer thread comes out of synchronized block, memory will not be synchronized, and the value of instance will not be updated in the main memory. With volatile keyword in Java, this is handled by Java himself, as such updates will be visible by all reader threads. So in summary, apart from synchronized keyword in Java, volatile keyword is also used to communicate the content of memory between threads. Okay, synchronized keyword write olanda lock eləyir, readləri lock eləmir. Düzdür? Bir dənə gəlin bunu soruşaq. Bayaq burada chatı mən görməmişim, uşaqlar indi gördüm. Salam hər kəsə. Deməli, atomik nə demək? Objeden bir tane yoksa ondan yarat, varsa direkt olan objeyi döndür. Böyle objeden bir tane olmasını sağla. Salam. Backend developer. İndi gəlin, okay, başa düşürəm yavaş-yavaş volatile hissəsini, amma bayaqki memory model hissəsinə çətinlik çəkdim. Deməli, synchronization sadəcə readdə lock eləyirdi, hə. It flush write operation into main memory which eliminates memory inconsistency error. Okay, burada nə deyir? Burada deyir ki, because reader threads are not doing any locking and until the writer thread comes out of synchronized block, memory will not be synchronized and the value of instance will not be updated in the main memory. With volatile in Java, this is handled by Java himself, and such updates will be visible all reader threads. So in summary, apart from synchronized, a volatile keyword is also used to communicate the content of memory between threads. Okay. Deməli. Yəni deyir ki, synchronization zamanı reader threadlər nə edir? Visible olmur, dəyişilir reader thread'ə. Bu reader threadlərə dəyişikliyin visible olması üçün də volatile istifadə edir. Let's see another example of volatile keyword in Java. Most of the time while writing games we use a variable bExit to check whether the user has pressed the exit button or not. The value of this variable is updated in the event thread and checked in the game thread. So if we don't use volatile keyword with variable, game thread might miss an update from event handler thread if it's not synchronized in Java already. The volatile keyword in Java guarantees that value of volatile variable will always be read from main memory, and the happens before relationship in the Java memory model will ensure that content of memory will be communicated to different threads. Okay. Check user position, update user position. In this code example, one thread can cache the value of bexit instead of getting it from main memory every time, and if in between any other thread, even handler thread changes the value, it would not be visible to this thread. Making Boolean variable as volatile in Java ensures this will not happen. Also, if you have not read about volatile variable from Java concurrency, okay, kitap okumak lazımdı deyir. Well, when to use volatile variable in Java. One of the most important things in the learning of volatile keywords is understanding when to use volatile variable in Java. Many programmers know what is volatile variable and how does it work, but they never really used a volatile modifier for any practical purpose. Here are a couple of examples to demonstrate when to use the volatile keyword in Java. You can use volatile variable if you want to read and write long and double variables atomically. Long and double both are 64-bit data types, and by default writing of long and double is not atomic and platform dependent. Many platforms perform write in long and double variable two-step, writing 32-bit in each step. Due to this possible for thread to see 32-bit from two different writes, you can avoid this issue making long and double variable volatile in Java. Volatile variable can be used as an alternative way of achieving synchronization in Java in some cases, like visibility. With volatile variable, it's guaranteed that all reader threads will see the updated value of volatile variables once the write operation is completed. Without volatile keyword, different reader thread may see different values. Visibility. Volatile variable can be used to inform the compiler that a particular field is subject to be accessed by multiple threads, which will prevent compiler from doing any reordering or kind of optimization which is not desirable in multi-threaded environment. Without a volatile variable, compiler can reorder the code free to cache value of volatile variable instead of always reading from main memory. Like following example, without volatile variable may result in an infinite loop. Okay. Without volatile modifier, it's not guaranteed that one thread you see the updated value is active from other thread. Free to cache value of is active. Another place where volatile variable can be used is to fix double-check blocking in singleton pattern. As we discussed, why should you use enum as singleton? that double-checked locking was broken in Java 1. Java 1.4 points on volatile keyword in Java. Volatile keyword in Java is only application to variable, and using a volatile keyword with class and method illegal. Java guarantees that value of volatile variable will be always read from main memory and not from thread's local cache. In Java, read and writes are atomic for all variables declared using Java volatile keyword, including long and double. Using volatile keyword in Java on variables reduce the risk of memory consistency error because in write volatile variable in Java, establish happens before relationship with subsequent read of that same variable. Java 5 changes to volatile variable are always visible to other threads. What's more, it also means that when a thread reads a volatile variable in Java, it sees not just the latest change to volatile variable, but also the side effect of code that lead up to change. Reads and writes are atomic for reference variables, are for most primitive variables, all types except long and double, even without use of volatile keyword in Java. Access to a volatile variable in Java never has a chance to block. We are only doing simple read-writes, so unlike synchronized block, we will never hold to any lock or wait for any lock. Java volatile variable sonra ne diyor? Has Java volatile variable that is an object reference may be null. Java volatile keyword doesn't mean atomic. It is common misconception that after declaring volatile be atomic to make operation atomic, you still need to ensure exclusive access using synchronized method or block in Java. If variable is not shared between threads, you do not need to use volatile keyword with that variable. Difference between synchronized and volatile keyword in Java. What is the difference between volatile and synchronized is another popular core Java question asked on multi-threading and concurrency interview. Çox yaxşı sayt uşaqlar. Əgər kimsə istəsə bunu göndərə bilərəm. Oy. Hə, çox əladır. Siz də baxa bilərsiniz. Multi-threading ilə bağlı interview questionlar var və əladır. Deməli, nə deyir? What is the difference between volatile and synchronized is another popular core Java question asked on multi-threading and concurrency interviews. Remember, volatile is not a replacement of a synchronized keyword, but can be used as an alternative in certain cases. Here are a few differences between volatile and synchronized. Keyword in Java is field modifier, while synchronized modifies code, block, and methods. Synchronized obtain and release log on monitors. Java volatile keyword does not require that. Threads in Java can be blocked for waiting for any monitor in case of synchronization. That's not the case with volatile keyword in Java. Deməli, synchronizationda log var, volatile'da heç bir log yoxdur. Java'da threadlər deməli waiting for any monitor in that case can be blocked for waiting for any monitor in case of synchronization. Synchronization deməli bloklayır. Amma volatile elə bir şey yoxdur. Synchronize method affects performance more than a volatile keyword. Bloklama və loklama olduğu üçün synchronize performansı deməli effect edir. Since volatile keyword in Java only synchronize a value of one variable between thread memory and main memory. Synchronize a value of one variable between thread memory and main memory. Since volatile keyword in Java only synchronize the value of one variable between thread memory and main memory, while synchronize the value of all variables between thread memory and main memory, and locks the release monitor to boot. Due to this reason, synchronized keyword in Java is likely to have more overhead than volatile. Okay. Deməli, nə demək istəyir? Volatile keyword in Java only synchronize value of one side. Deməli, value of one side between threads and memory. Sonra nə deyir? Deməli, volatile declare olunan variable'ın dəyərini threadlərin memorisi arasında və main memory'də deməli nə edir? Synchronize edir. Amma synchronized keyword threaddəki bütün variable'ların dəyərini threadin memorisi və main memory arasında synchronise edir və monitoru lock və release edir. Bu səbəbdən də synchronized keyword daha deməli is likely to have more overhead. Overhead, above level of the head in the sky. Cost expense daha bahalıdır arkadaşlar. You cannot synchronize on the null object, but your volatile variable in Java could be null. Deməli, volatile variable'ımız null ola bilər, amma biz null bir obyekt üzərində synchronization edə bilmərik. From Java 5, writing into volatile variable has the same memory effect as monitor release, and reading from volatile field has same memory effect as monitor acquire. Mən nə deyir? Java 5-dən etibarən volatile variable'a deməli write etmək, monitor release qədərin effekti var. Read etməkdə monitor acquire etmək qədər effekti var. Əksin olmalı deyildi. Mən gözləyərdim ki, əksi olsun. In short, the volatile keyword in Java is not replacement of synchronized blocker method, but in some situations very handy and can save performance overhead, which comes with use of synchronization in Java. If you like more about, okay, happens before'a gedər indi. Sadəcə olaraq bir məsələ var. Bir dənə bu volatile, how volatile works, use variable-ını bilirik. Memory-də necə işləyir? Bir dənə bu hissəyə təzədən baxaq. Example of volatile keyword in Java, singleton pattern in Java. Deməli, singleton, get instance null-dırsa, hansı ki volatile dedik, null ola bilər, amma synchronized null obyekt üzərində ola bilməz. Singleton, get instance, null-dırsa, singleton class üzərində bir dənə log. İnstans nə oldusa yenisini yaradırıq. If you look at the code carefully, you will be able to figure out what we are only creating instance. We are only creating instance one time. We are creating instance lazily at the time first request comes. If we bir dənə bura çatayıq ki, artıq baxıram, görməmişəm. Okay. I wish I can edit this. Let's remove. Okay, cool. We are only creating instance one time. We are creating instance lazily at the time the first request comes. If we do not make instance variable volatile, then thread, which is creating an instance of singleton, is not able to communicate other thread. That instance has been created until it comes out singleton block. Nadir. If we do not make instance variable volatile, then thread which is creating an instance of singleton is not able to communicate other thread. That instance has been created until it comes out of a singleton block. So if thread I is creating singleton instance and just after creation lost the CPU, all other thread will not be able to see the value of instance as not null, and they will believe it's still null. Okay. Main memory. Because reader thread are not doing any locking until the writer thread comes out of synchronized block, memory will not synchronize and will not be synchronized and the value of instance will not be updated in the main memory. Java volatile keyword handles Java himself, such update will be visible. Okay, bir dənə bunu bir dənə dəqiqləşdirək. Bayaq dəqiqləşdirməyi unutdum. I will not be synchronized. Okay, reader thread comes out of synchronized block. Reader threads are not doing any locking until writer thread comes out of. I'm not doing any locking until writer thread comes out of synchronized. Okay, başa düşdüm. Mən deyirəm ki, nə? Yəni deyir ki, reader thread heç bir lock eləmir, yəni işə başlayıb oxumur. Nə vaxta qədər writer thread unlock edir. Synchronized blockdan çıxır çölə. Okay. Not doing any. What does reader thread does not need log? No. Double check locking with volatile pattern in Java. Double check locking. I didn't know that. Deməli bu ona görə double check locking. First check no lock. Second check with lock. First check fast pass. Most call skip locking if instance is already initialized. Synchronize block only taken when instance is still null. Okay, başa düşdük. Yəni bu double check-in məqsədi odur ki, birinci check əgər bu onsuz da null deyilsə, sürətli şəkildə check eləsin. İkinci check isə məqsəd odur ki, əgər nulldırsa lock edib check eləsin ki, ola bilər başqa thread tərəfindən initialize olundu həmin anda. Deməli, synchronize block only taken when instance is still null. Second check ensures only one thread actually creates singleton. Volatile guarantees visibility and prevents reordering of constructor page steps. Does reader thread needs a lock? No. After initialization, reader don't need locking. Volatile guarantees visibility once one thread assigned. Okay. Reader thread does not need lock deyəndə bu hissəni nəzərdə tutur. Double check. Okay. Every other thread çünki volatile guarantees visibility across all threads. Will eventually see the write immediately. No state cached value. Birbaşa main memory'dan oxuyur. Volatile also prevents reordering. Without it, JVM could reorder writes instance points to an object reference before constructor finish. JVM could reorder writes, so in instance point to an object reference before constructor finish. Bunu bir dənə nümunə ilə göstərsin. Show an example. Explain this again. Save to just read volatile reference, no synchronization need. Write thread locking. The lock ensures only one thread runs a constructor. Reader never enter critical section once instance is set. Volatile ensures they don't miss initialized object. So reader doesn't need lock because volatile write makes fully initialized instance safe or visible to them. Without volatile, it breaks. Imagine no volatile thread enter synchronization, allocate memory, assign reference instance. Okay, deməli volatile'ın istifadəsi daha az lockingdir. Hansı ki biz burada double check edirik. Double check locking birincidə biz volatile istifadə edədiyimiz üçün belə yoxlayırıq. Nəticədə bütün threadlər tərəfindən görünür. Əgər bu hələ də nulldırsa biz artıq synchronize check edirik. Hansı ki nə edir? Qarşısını alırdı ki, digər thread tərəfindən bu update olsun. Okay, cool. Əla başa düşdük. Does first check points to partial constructed object. Allocates memory, assign reference instance now points to partial constructed object. Does first check sees not null and returns that half checked object. Crash or weird behavior. Exactly why volatile mandatory in Java double checked a locking pattern. Synchronize ensures only one writer thread runs. Volatile ensures visibility across threads. Together make double checked locking safe in Java 5+. JVM doesn't treat it as one atomic operation. It's actually two sequential steps. Allocate memory for object, initialize object, run the constructor, assign reference to instance. Ne deyir? Allocate memory for object, initialize object, assign reference to instance. What can happen without volatile? Compiler is allowed to reorder step 2 and 3. Allocate memory, assign reference to instance variable, and initialize object. So instance variable is no longer null, but constructor hasn't finished yet. Base is instance run singleton constructor. Partial build object. That's half constructed object. Yani tam olarak referansı assign eləmir. Initialize object eləməyib. Çünki initialize eləməyib, sadəcə adresi buna, referansı buna set eləyib. What happens with volatile? When instance is declared volatile, two rules kick in. Visibility guarantee writes to instance are immediately visible all threads. Reordering guarantee cannot reorder. Volatile cannot reorder the assignment before the constructor step 2. Now the timeline is forced. Allocate memory runs constructor fully. Assign instance fully built. Says non-null. Okay. Başa düşdük. Əla. Əla. Difference between transient versus volatile variable or modifier in Java. Transient. What's this? Use a signal thread and compiler. Runtime optimize it like JIT and use val in particular. Variable is going to be updated by multiple threads inside Java. Main variable volatile, use volatile keyword in Java. Okay, burada baxmaq olar. Bu değil. Bu yeni değil.
Hello there, and welcome to the Java Masterclass. I'm Tim Bacalca, your instructor, and I'm excited to have you here. I've been programming for over 40 years with close to 25 years of those dedicated to Java. My goal is simple.
Bana bir kursundan farklıydı, okay. Bu. Okay, açmadı. Java development bootcamp. Yaxşı, belə ucuz. Ucuz yeni indirmə düşübdən. Neyse. Okay. What is this? Now dear, there are multiple ways to traverse or loop through map, hash map or tree map in Java. Okay, tree map hakkında da okuyarıq. And we are all familiar with either all of those or some of those, but to my surprise, one of my friends was asked in his interview, he was more than 6 years experienced Java, to write code for getting values from hash map, hash table, concurrent hash map, tree map, Java in at least 4 ways. Just like me, he was also surprised by this question, but written it. I don't know why exactly someone asked this kind of question. Java interview, senior Java programmer, so my closest guess. Anyway, gives idea right. Çox bir qəribə bu sual. Traverse, iterate, loop in map in Java. So remember this because you may also ask this question. See 4 different ways of looping, iterating through over map. We'll display each key and value from hash map. We will use the following hash map for our example. You can see that it contains just 2 mapping, which means only 2 keys and 2 values deal with. Okay, map deməli interface'de burada abstract map, sorted map bu interface'i implement edilir. Ve hash map, tree map, linked hash map, hash table'da dictionary'den gelir. Hem map hem de ki dictionary'ni implement edilir. Okay. Bunu yadda saxlayaq. Tree map, sorted map və abstracted map deməli neyir? Implement edir. Iterating over loop or looping using Java 5 for each keyword. Okay, for each using key set. Key set has next. Instead of for a similar earlier example, one advantage of using iterator is that also allows you to remove keys and entries while iterating. For'da biz deməli iterate eləyərkən remove eləyə bilmirik, amma has next-də eləyə bilirik. You can remove particular key from key set and entry from entry set to actually delete that value from the map. Key set iterator has next. Key value once get key. Using entry set has next. Get key. Okay, entry set. Nədir? Entry set iterator. Entry set iterator while. Nə dəxlisiz sual, neysə bu getdi. Tree map is sorted map. Okay, buna indi baxaq mı? Bunu saxlayaq hələ ki. Deməli. When I started Java programming, I didn't know what is Java heap or heap space in Java. I was even not aware of where does objects in Java get created. It is when I started doing professional programming, I came across errors out of memory. In Tomcat, I realized what heap in Java or what heap space. It happens with most of the programmers because learning language is easy, but learning basics are difficult since there is no formal process which can teach you every basic programming. It's experience and work which relieves the secret of programming. For Java developers' knowledge of Java, heap in Java, setting the size of Java heap space, dealing with Java heap space out of memory error, analyzing heap dumps is very important. You should read Java Performance from Charlie Hunt to learn more about how to troubleshoot Java performance issue, profiling and advanced tools to take heap dump and analyze it from problem areas. This Java heap tutorial is for beginner brothers who are new in programming, and it makes too much difference if you know the basics and underlying until you know the object is created in heap. You won't be able to think why occurs in Java. Nadir, it makes too much difference if you know the basics and underlying until you know that object is created in heap. You won't be able to think why out of memory occurs in heap. I'm trying to provide as much as information about heap as I know, but would like you guys to contribute and share. By the way, if you are confused between heap and stack, which where your local variables get created, you can also check. Okay. Okay. Kitap okumak lazım diye. Qısa bir şey də oxuyaq bunu. Mən stack və heap arasındakı fərqi məncə bilirəm. Difference between stack and heap memory is common programming question asked beginners learning Java and other programming. Stack and heap memory are two term programmers start hearing once they start programming, but without any clear and definite explanation. Lack of knowledge of what heap in Java and what stack memory in Java result in misconception related to stack heap. This confusion, stack is also a data structure that's used to store elements in LIFO, last in first out order, and is available in Java API as Java util stack. In general, both stack and heap are part of memory. A program is allocated and used for different purposes. Java program runs on JVM, which is launched as processed by the Java command. Use both stack and heap memory for different needs. 10 points in Java heap space. I have touched base on Java heap space, and in this article we will see difference between stack and heap memory in Java. A few differences between stack and heap memory. The main difference between stack and heap memory is that stack memory is used to store local variables and function calls, while heap memory is used to store objects in Java. No matter where the object is created in the code, as a member variable, local variable, or class variable, they are always created inside heap space in Java. Each thread in Java has its own stack, which can be specified using the XSS JVM parameters. Similarly, you can also specify heap size of Java program using JVM options XMS and XMX, where XMS is starting size of heap and XMX is the maximum size of Java heap. To learn more about JVM, see my post. Ben bunu bilmirdim. Heap size'ına özümüzün adjust edə biləcəyimizi. Reference value reference stack heap. If there is no memory left in stack for storing function calls or local variables, JVM will throw stack overflow, while if there is no more heap space for creating object, JVM will throw out of memory error, Java heap space. Read more about how to deal with out of memory in my post solve out of memory error. Okay. If you are using recursion on which method calls itself, you can quickly fill up stack memory. Another difference between stack and heap is that size of stack memory is not lesser than size of heap memory in Java. What? Is lot lesser than size of heap memory in Java. Səhv oxumuşam. Variable stores in stack are only visible to the other thread. Mən niyə yanlış oxuyacağam? Variable stored in stack are only visible to owner thread, while objects created in heap are visible to all threads. In other words, stack memory is kind of private memory of Java threads, while heap memory is shared among all threads. That's all difference between heap and stack memory in Java. As I said, it's important to understand what is heap and stack in Java and which kind of variables goes where. You can nəsə. Hayır, bu getdi. Buraya indi gələk. Premium 10 points. Java heap memory. Okay. What is heap space in Java? When Java program starts, Java virtual machine gets some memory from the operating system. Java virtual machine or JVM uses this memory for all its needs, and part of this memory is called Java heap memory. Heap in Java generally located at the bottom of address space and move upwards whenever we create an object using a new operator or by any other means. The object is allocated memory from heap, and when object dies or garbage collected, memory goes back to heap space in Java. Garbage collection works. Okay, geriye belki mevzulara garbage collection falan. Survivor space, hidden, young generation, old generation, permanent generation. To increase heap size in Java, the default size of heap space in Java is 128 megabyte. On most 32-bit sans JVM, but it highly varies from JVM to JVM. Default maximum start heap size for 32-bit Solaris operating system is XMS 3670 kilobyte mı? Values heap size parameter on have been increased up to approximately 35%. Also, if you are using throughput garbage collector in Java 1.5 default, maximum heap size of JVM would be physical memory divided 4, and default initial heap size would be physical memory divided 16. Maximum heap size physical memory divided 4. Initial heap size would be physical memory divided 16. Bunlar çox maraqlı məlumatlardır. Another way to find the default heap size of JVM is start an application with default heap parameter and monitoring using G-console, which is available on JDK 1.5 onwards. On the VM summary tab, you will be able to see maximum heap size. Increase size of Java heap based on your application. Burada başka ne olmaz? Garbage collection, hotspot, tree map, out of memory, synchronization happens before. Necə gəldim buralara çıxdım ya, heap filan, double check. Bunu oxuduq. Bu çox çətin də deyil. Çox sağ olun, təşəkkür edirəm. Sizə də uğurlar arzu edirəm koddən də. Okay. Gəlin istəyirsiniz heap hissəsindən filan bitirək, memory hissəsindən. Sonra ardından bu synchronization filan buralara gedək. Tree map, example hotspot, JVM options. Hətta bunu bura çəkək. Bunu da bura. Ama neyse, bunu gəlin bitirək. 1, 2, 3, 4, 5 hissə qaldı. Bunu bitirək. Sonra qalandan sabah davam edək. Ay, bu heç bitənə oxşamır. There's another parameter called xmn, which denotes the size of new generation of Java heap space. The only thing you cannot change the size of heap in Java dynamically. You can only provide Java heap size parameter while starting JVM. I have shared some more useful JVM options related to Java heap space and garbage collection on my post. No, you may find useful. Hotspot, okay, bunu bayaq gördük, bunu buradan götürürük. Deməli, biz nə edirik? Start eləyəndə initial heap size set eləyə bilərik, maximum heap size set eləyə bilərik. Young generation'ın saxlanacağı hissəni set eləyə bilərik. XMN denotes size of new generation of Java heap space, amma dynamically heap'in size'ını dəyişə bilmərik. I have shared some useful JVM options related to Java heap space and nəsə bunu baxarıq. Regarding default heap size in Java from Java 6 update 18, there are significant changes in how JVM calculates default size in 13 and 16-bit machines on client and server JVM mode. Initial heap size and maximum heap space. Initial heap space and maximum heap space is larger for improved performance. The default maximum heap space is half of physical memory of size up to 192 bytes and 1/4 of physical memory for size up to 1 gigabyte. So 1 gig machine's maximum heap size is 256 megabyte. To maximum heap size will not be used until the program creates enough objects to fit initial heap space, which will be much lesser, but at least 8 megabytes or 1 divided 64th part of physical memory up to 1 gigabyte. Deməli 1 gigabaytlıq physical memory üçün maksimum heap size onun yarısı qədərdir. Və initial heap size ise 1 GB üçün 1 bölünsün 64, at least 8 megabayt olur. Yox. Maksimum heap size normalda 1 bölü 2'dir. Ama 1 GB olanda 1 bölü 4 olur. Ve initial'da 1 bölü 64 olur 1 GB için. For server Java virtual machine, default maximum heap space is 1 GB for 4 GB, yani 1 bölü 4. Physical memory on 32-bit JVM. For 64-bit JVM, it's 32 GB for physical memory of 128 GB. Yani 4'te 1'i. To learn more about how much memory you can set in 32-bit and 64-bit JVM in various operating systems, maximum heap size 1 bölü 4'tü. Initial heap size 1 bölü 64'tü. Garbage collection. As we know, objects are created inside heap memory, and garbage collection is a process that removes dead objects from Java heap space and returns memory back to heap in Java. For the sake of garbage collection, heap is divided into 3 main regions named as new generation, old and tenured generation, and perm space. New generation of Java heap memory is part of Java heap memory where a newly created object is stored. During course of application, many objects were created and died, but those remain live. They got moved to old or tenured generation by Java garbage collector thread on major or full garbage collection. Perm space of Java heap is where JVM stores metadata about class and methods, string pool, and class level details. You can also see the Java and garbage collection online courses. Bu nə yaxşı blog saytıdır, hər şey var. Java memory management, heap stack, meta space, object on heap memory stack. Class loading and reflection. Önce reflection nədir onu öyrənməliyim, sonra buna baxmalıyım.
Hello and welcome to this course on Java Application Performance. My name is Matt Greencroft and I'm going to be your instructor on this course. In this course we're going to consider how to improve the performance of applications running on the Java virtual machine, or maybe to avoid mistakes that can lead to poor performance in the first place. By performance, I really Welcome back. This is chapter 4 and it's the start of a major topic in this course, which is how memory works in Java.
Between methods. Pass by value. Ay, bu pass by value, pass by reference. Bunu da öğrenmen lazım da. Bu arada Java pass by value language'de. Bir defa daha okumuştum. Is Java pass by value or reference? Burada. Hatta ben bunu yazmıştım ben. Oh my god. By those definitions, Java is always passed by value. Unfortunately, when we deal with variables holding objects, we are pass by value de neye göredir? Çünkü biz değerini ötürürük. Referansın değerini veya variable'ın değerini. Sen falan ramsey elə deyirdi. We pass object to max or to a dog. We pass object to foo. A dog variable is still pointing to max. Dog when foo returns. Foo. Burada get name equal max true. The equal new dog fifi. True. Change the inside of foo point new dog inside construct with red. Construct red with name member variable set to pp. Bunun içerisine değişti. Bu da true'du. False'du çünkü buradaki değerini değişip bu. Buradakini yok. A dog get name. All dog true. A dog get name still returns max. A dog within main is not changed in function foo by creating new dog with name member variable set to fifi because object reference is passed by value. If the object reference was passed by reference, then object in main would return fifi. Object reference passed by value. Değer ötürüldü. Likewise, max, old dog, foo, set name fifi, fifi true. In this example, Fifi is a dog name after call to foo a dog because object name was set inside foo, an operation that foo performs such that for particular purpose they are performed on a dog. But this is not possible to change value of the variable a dog itself. For more information on pass by reference, following answer. Neyse buna bakar. Out of memory error in Java heap. JVM heap space is equal to the initial size of heap specified by GMS parameter. As the application progresses, more objects get created and heap space is expanded to accommodate new objects. JVM also runs garbage collection periodically to reclaim memory back from dead objects. JVM expands heap in Java somewhere near to maximum heap size specified by XMX, and if there is no more memory left for creating new objects in Java heap, JVM throws out of memory and application dies. Before throwing the null space, JVM tries to run a garbage collector to free any available space, but even after that, not much space available on heap in Java, it results in out of memory error. To resolve this error, you need to understand your application object profile, what kind of objects you are creating, which objects are taking how much memory. You can use profiler or heap analyzer to troubleshoot out of memory. Error message donates that Java heap does not have sufficient space and cannot be expanded further, while error message comes when permanent generation of Java heap is full. Application will fail to load a class or to allocate an intern string. How to increase Java heap space on Maven and Ant. Many times we need to increase heap size of Maven or Ant because once number of classes increase, build to require more memory process and build more often out of memory, which can avoid changing or increase heap memory. What's that? Where you analyze and troubleshoot any memory leak in Java or any out of memory error. Tools available inside JDK which helps you to take heap dump, and there are heap analyzer available tool which helps you to analyze Java heap dump. You can also use gmap command to get Java heap dump, and this will create heap dump file. Then you can use ghead Java heap analyze tool to analyze that heap dump. Okay, deməli gmap, daha sonra ghead. You should also read it's one of the most read Java performance book for any senior Java developer. I'm not senior Java developer, but olmaq istəyərəm. Top 5 books. Optimizing Java, troubleshooting Java, Java performance companion. Ayda çox şey oxumaq lazımdır. Bunlar gördükcə adam gözü qorxur. Java heap memory is part of memory allocated to JVM by operating system. Whenever we create objects, they are created inside heap in Java. Heap space divided into three regions or generation for sake of garbage collection called new generation, old, or tenured generation, or perm space. The permanent generation is called garbage collected during full garbage collector in hotspot JVM. You can increase or change size of heap space using JVM commands lines using GMS, GMX, and GMN. Do not forget to add words M or G after specifying size to indicate mega or gig. For example, you can set Java heap size to 258 megabyte per executing following command: Java GMX M hello world. You can use either gconsole to or runtime max memory, runtime total memory, runtime free memory to query about heap size programmatic in Java. See my how to find memory usage in Java program module. You can use command gmap to take Java to take heap dump and ghead to analyze heap dump. Heap space is different than stack, which you store call hierarchy and local variables. Java garbage collector responsible for reclaiming memory from dead objects and returning Java heap space. Don't panic when you get out of memory. Sometimes it's just a matter of increasing heap size, but it's still recurrent when look memory leak in Java. Dəhşət. 2021'de yazılıb bu. What's that? Ay bu oku bitmez. Okay. Okay. Garbage collection mağazadan sabah baxa. Salam Əli, çox sağ ol. Çox qəribə şəkildə bu səhifəni tapdım. Əslində volatile necə işləyir falan onu oxuyordum. Sonra gəldim memory model, nə bilim heap stack, indi də garbage collection'a gəlib çıxmışam. Dedim bunları sizə bir də keçim, maraqlı gəldi. Volatile necə işlədiyini başa düşdüm, synchronize ilə arasındakı fərq falan. Burada bir neçə hissə qalıb synchronization ilə bağlı. Java volatile, amma məncə eyni işləyirlər yəqin ki, hə? Java'da da var, hə? Görün burada hardadır. Burada how volatile works. main memory'dən oxuyur hər dəfə onu. CPU registrdə və sarkeşdə resetləməsinin qarşısını alır. Hə, amma mən hər dəfə bunu qarışdırırdım. Başa düşmürdüm ki, volatile niyə istifadə etmək lazımdır. Oxuyan sonra daha aydın oldu. Və məcbur edir ki, hər dəfə lazım olanda CPU onu memorydən oxusun. Eynən. Volatile read heavy operationlarda tətbiq edilir. Bir də double neydi? Double check blocking. Okay. Volatile və synchronization bir yerdə istifadəsini oxudum. Və təbii ki, multi-threaded senaryodan gedir söhbət. Yeah. Singleton pattern, aha yadımdadır. Burada volatile'ın bir yerdə istifadəsini də izah elədi. Bu deməli article. Double check blocking falan nəyə lazımdır onu da başa düşdüm və multi-threaded thread save singleton pattern'i necə tətbiq edə bilərsən? Instance volatile əslində bunu oxuyur, elə buradakı kimi instance volatile edirik, bir də double check blocking istifadə edirik. Buradakı deməli lock eləmənin hər dəfə lock eləmənin qarşısını almaq üçün yoxlayırıq. Əgər null deyilsə elə instance return edirik. Nullsa da yoxlayırıq ki, başqa thread tərəfindən yaradılmayıbsa biz yenisini initialize eləyək. Hər iki if'i izah edə bilərsən. Məsələn, birinci if olmadan birbaşa ikinci if olsa olmaz. Olar, amma bu dəfə hər check edəndə lock edəcək. Bu da performans üçün yaxşı deyil. Çünki volatile birbaşa daha light'dır, deməli bu synchronize keyworddən. Çünki lock tətbiq eləmir. Beləliklə volatile sayəsində hər dəfə gedib main memory'dən oxuyacaq, orada görünəcək dəyişiklik. Bu ona kömək edir ki, görsün digər thread tərəfindən initialize olunub, yoxsa yox. Əgər digər thread tərəfindən initialize olunmayıbsa, artıq biz burada lock tətbiq edirik və yoxlayırıq ki, görək. Initialize olunmayıbsa, biz initialize edək. Əks halda partially initialized ola bilər. Bu da sonra crash falan edir program. Reference leak falan belə bir şey deyəsən baş verə bilər. Birinci referans əslində burada 3 proses baş verir. Birinci memorydən yer ayrılır, initialize olunur, sonra isə referans set olunur. Volatile olmadıqda bu reorder olur həmin proses və partially initialized object yarana bilər. Başqa hansı yolunu bilirsən thread save singleton'un? Əslində başqa yolunu bilmirəm. Elə birinci bunu görmüşdüm. Bu ağlımda qalmışdı. Thread save singleton başqa nə etmək olar? Elə birbaşa bu get instance metodunu synchronize eləmək olar. Static constructor'da set edə bilərsən instansı. Static constructor'da. Static constructor nə işə yarayır? Hər bir thread'in özünün static variable'lar yox. Static constructor özü thread save execute edilir. Yəqin ki var. Var olmalı. C#'da adı Mənədir, cavabı fərqli olmalı. Static constructor yoxdur. In C# you can explicitly declare static constructor exactly once per type before any static member are across or any instance is created. There is no direct keyword or syntax for static constructor. Instead, Java provides static initialization block. Okay. You can also initialize static fields inline. Static block eyni iş görür static constructor ile. Both approach achieve something similar to C# static constructor. They execute once when the class is first loaded by JVM. They are used for initializing static variables or running classical setup logic. Static blockla singleton implementasiyasını istəyəcək bizdən. Implement singleton with static block in Java. Blokun içərisində check edəcək həmin o instance variable. Singleton instance created. Instance equal new singleton return instance. Bu check eləməli deyildi burada. Hər dəfə bir dəfə run olacaq. Check etməyə ehtiyac yoxdur, çünki static block özü thread save işləyir. Class load olanda bir dəfə run olur. Okey, başa düşdüm. İki thread run edə bilməz o bloku. Burada artıq volatile, synchronize heç bir şeyə ehtiyac yoxdur, hə? Can I implement singleton in Java? Save singleton in Java. How many ways? Ama bu yanaşma istifadə edilmir. Ən çox double check istifadə edilir. Bu yanaşma niyə istifadə edilmir bəs? Double check blocking. 6 yolu var imiş. Default choice enum singleton need lazy without framework holder pattern. Çünkü bu yanaşmaya göre type RAM'a yüklenen kimi static blok işe düşecek ve instance yaranacak, ancak belki de hiç bize o instance hiç lazım olmayacak. Əlavə yer tutur. Get instance ise bize metod çağıranda instance yaranacak. Okay. Məntiqli. Heç çağırmasaq instance'da heç yaranmayacaq. Okay. Başa düşdük bunun. Enum singleton. Bu ne inir bəs? Static class, static final. Holder. Get a holder.instance. Place zero thing overhead. No resistance to serialize reflection by default. Static final, new app config. Private constructor. Return instance. Tribal inherently thread safe, not lazy, may initialize even if never used. Onda bu da yaxşı deyil. Eager initialization. Simple instance created when class loads. Thread safe without synchronization using class loading. Bu da class loading istifadə edir. Resistant to serialization, reflection trick. Static block initialization like tree, but you can catch handle exceptions. Instance static block. Bayaq ki Can handle checked exception on initialization. Not lazy. Synchronize accessor. Full hedge. Edge access. Bu double check bildik. If you use 2, 3, 4, 5, 6 initialization on demand either static block and care about absolute oneness. Reflection nədir? Bununla bağlı bir tane kurs almıştım. Prosto bakmadım. Ay. Kaldı. Okay. Reflection gated dolasının uçlardan. Ben buna sonra bakmadım. Buna da bakarım. SQL pagination ve dynamic işleyen Excel kitapxanalar istifadə edir. Okay. Bu kurs 5 saat olmalıydı. Elə buna baxarım. Bax. Bu adam çox yaxşı izah edir. Aslında burada dayandıra bilərəm. Adını görmürsünüz. Okay. Mən də adını tələffüz edə bilmirəm. Ona görə tələffüz edəmədim. Nə de bu. Multithreading kursuna baxmışdım. Orada izahı çox yaxşı idi. Ona görə güman edirəm ki, bunu da yaxşı izah edib. Ama bu notlar hissəsində deadlock'a qədər gəlmişdik. Əslində buradan davam edə bilərəm, amma buradan davam eləməmişdən əvvəl istəyirəm ki, buradakı synchronized filan bunları oxuyum. Bunları sonra deadlock'dan davam edeyim. Bugünlük yayını yekunlaşdıraq. 2 saat yarımda artıq. Çoxdan da bu qədər uzun yayın eləmirdim. Bugün çox maraqlı oldu. Bu səhifəni tapdım deyə birini oxuduqca digəri gəlirdi. Maraqlı oldu. Belə. Sabah da ardından davam edərik. Çox sağ ol. Heç nə uşaqlar. Bugün yekunlaşdıraq. Sabah ardından davam edərik. Hələlik. Sağ olun. Özünüzə yaxşı baxın. Sabah görüşənədək.